We are going on with circle geometry, and in this example we want to determine the values of x and y. What we are given is that the angle EDB is equal to x and that the angle DEC is equal to y. We are also given that DKC is 70 degrees and that the angle A is 40 degrees. Now what I would like to do with questions like this, I start with the angles that are given to me. So let's start with this 70 degrees. I notice that this 70 degrees is connected to x and y as an exterior angle of a triangle. That means that x plus y would be equal to 70 degrees. So we can write it as x plus y is equal to 70 degrees, and our reason is exterior angle of a triangle. Next, let's move on to the second angle that was given, and that is 40 degrees. So if I highlight the arms of the angle connected to 40 degrees, I can see another triangle forming. And what I notice is that angle C1 is equal to angle X, because those form angles in the same segment. So we can say angle C1 is equal to X, and our reason is angles in the same segment. Then I look at the 40 degrees again and I notice a triangle, and if I extend the line of one of the legs, I can see that y is the exterior angle of this triangle, and we know that C1 is equals to x. That means that y is equals to x plus 40 degrees. So y is equal to x plus 40 degrees, and our reason again is exterior angle of a triangle. Now we have two partial solutions. We have x plus y is equals to 70 degrees, and that y is equals to x plus 40 degrees. Now if you've learned simultaneous equations, you know you can take the first equation and rewrite it as x plus 40 degrees is equal to 70 degrees. So what I'm doing is I'm replacing this y with the y that's equal to x plus 40 degrees. And that simplifies to 2x equals to 70 minus 40, which makes it 30 degrees. And therefore x is equal to 15 degrees because I divide by 2. That will mean that y is equals to 15 degrees plus 40 degrees, which makes it equal to 55 degrees.